Good morning, geometry students, and welcome to section 2.5, which is algebraic proofs. We're going to be dealing a lot with the algebraic properties of equality and also a little bit of the geometry version of that, of properties of congruence. As we work through different equations, we're going to be listing the different properties that go along with it. So hopefully you're having a good morning. This one could get a little bit tough as we're getting into different types of proofs, which is one of the hardest things in geometry. So make sure you're paying attention. Try and learn these properties as best you can as we go through this. I'll give you a free app, which will have some of the properties listed for you, along with some definitions, which might help you when it comes test or quiz time, so you don't have to write every single property down, although I don't think it would hurt you, because it'll help you memorize them, so that way you're not having to look them up each time that you do a proof. Where we could use this at, if you're ever going to be a game designer, which would kind of be a cool job, some of those you have to be able to use equations in order to simulate how fast you want to run, or what level you're going to tackle a person at, or so on and so forth. The number 5, we might start putting that in our notes and summary, which hopefully you're doing in Edu Creations and emailing those to me. Alright, here's the first list of properties. These are properties that we use to solve equations that we've done all through Algebra 1 and probably before that to this point. The addition property just allows us in an equation to add the same thing to both sides, and it keeps the equation balanced. Same thing with subtraction. If we have an equation, we could subtract the same thing from both sides, keeps the equation balanced. Same thing with multiplication and division, just allows us to multiply both sides by the same thing and not change the equation's value. Same thing with division. As long as it's a non-zero number, we can divide the same thing from both sides and keep it balanced. Substitution, if we know what a is equal to, then we can substitute that value in for a throughout the expression or equation and not change its value. So you might make a quick note of those. You can pause this as needed. I'm going to go on to the next page. A couple more properties. Maybe we haven't used them quite as much, so you might want to write them down. The reflexive property, with any real number, that real number is equal to itself. So 2 would be equal to 2, or a would equal to a, 5 would be equal to 5. A good starting point sometimes if we don't have somewhere to start on a problem. Reflexive property might allow us to start there. Symmetric property just means if we have a is equal to 2, then we'd know 2 is equal to a. So we can just flip-flop those around and interchange both sides of the equation. That doesn't change the value of it. The transitive property, well, this is if we know that a is equal to b and b is equal to c, then a and c must be equal to each other also. So that's the transitive property. Alright, a proof, and this is where we're going to be heading here in the next couple of sections. So a proof is just an argument using logic. Mainly it's just that, but we also use definitions, properties, and previously proven statements to show that our conclusion or our conjecture has to be true. Okay? So proof again is just an argument that uses logic, definitions, properties, or previously proven statements to prove our conjecture true. Right down here we're going to have our first example from section 2.5, algebraic proofs, and it wants us to take the equation 4m minus 8 equals negative 12 and justify each step into this. So I'm going to write given right over here because we're given this problem in the or given this statement in the problem. So the first thing when we're solving for m, we've got two things we've got to get rid of. We've got to get rid of the minus 8, and we've got to get rid of the 4. Now remember, when we're solving equations, we kind of want to use reverse order of operations. So therefore, we want to take care of this subtracting 8 first. So one of the properties that allows us to do that is we could add 8 to both sides And when we add 8 to both sides, we'd have 4m equals negative 12 plus 8 would be negative 4. So this would be the addition property of equality. So I'm going to, and you can go ahead and abbreviate like this also. And then we still need to get rid of the 4. So what allows us to do that, the opposite of multiplying, would be dividing by 4. So we'd have m equals negative 1. And what we use to get to this would be the division property of equality. So not a very long problem there. We just used 3 justifications to get to our answer on that one. Let's see if we have another example right over here. Yes, we do. We've got 1/2 x equals negative 7. That's our given. So we need to get rid of this 1/2. A couple of different ways actually to go about doing this. We could multiply by the reciprocal, which would probably be the easiest way to do here. And we would go straight to our answer then. Or we could divide by the 1/2. I'm going to go ahead and divide by the 1/2. Okay, to get rid of the 1/2s here. And now I've got to take negative 7 divided by 1/2. This will be a good opportunity to review you on dividing by fractions. So the first thing I'm going to do is put that negative 7 over 1. So I'm going to have negative 7 over 1. I'm going to keep it, change it, and flip it. Hopefully you've heard that 100 times coming into geometry. But that, and now we just multiply straight across on this, which would be negative 14 over 1. So that will give me negative 14 is equal to x. So what property did we use here? That would have been the division property of equality. Alright. Regular geometry students would be doing these problems at this time. We're going to go ahead and move on in the iPad initiative class here. Looks like we've got a long story problem here. We're going to try and read through it and maybe underline some things as we go through it so that when it comes time to work our problem down here, we'll have everything that we need underlined. It says to simulate the motion of an object in a computer game, the designer uses the formula SR equals 3.6p. To find the number of pixels the object must travel during each second of simulation. In the formula, S is the desired speed of the object in kilometers per hour. Then it says R is the scale of pixels per meter, and then P is the number of pixels traveled per second. Alright, the graphics in the game are based on a scale of 6 pixels per meter. The game designer wants to simulate a vehicle moving at 75 miles per hour. How many pixels must the vehicle travel each second? Let's see, solve the equation for P and justify each step. So it looks like we're looking for P. So I'm going to go ahead and just write the formula down here. And when something is given to me in the problem, or my starting place, my justification would just be given. So I'm going to write given right there. Now, let's see, 6 pixels per meter looks to be my R. So I'm going to plug that in for R here. Just 6. I'm going to copy this 3.6 and the P down. And then I'm probably given something for S here. So the only other thing I'm given is 75 kilometers per hour. Notice that that is what S represents, the speed of the object in kilometers per hour. So I'm going to plug in 75 right here. So it looks like I need to solve this, and my justification for that step would be substitution. So I just substituted in from the given information. up above. So now I need to multiply. It looks like 75 times 6. So I'm going to come up here real quick and multiply that out. So it looks like 450 would be multiplying that out. Now I need a justification for that. When I'm just multiplying two things that are given to me or I substituted in there, all I'm going to use for the justification is simplify. Alright. Well, to finish solving this, it looks like I need to divide by 3.6 to undo multiplying by 3.6. So it's going to cancel out over here. And I'm going to go ahead and go to my answer here. But I'm going to go ahead and break out the old calculator real quick. So I'm going to have 450 divided by 3.6. And it looks like 125 would be my P, which is the pixels that the vehicle must travel each second to represent the 75 kilometers per hour. Alright, now my last step here would have been division property of equality. Alright. So let's see, regular geometry class would be doing those problems at this time. I'm going to go ahead and stop this video. We're going to call it section 2.5 part 1. So we'll see you just as soon as you're ready for part 2.